Welcome to this special interactive explainer. Today, we're putting your knowledge of data science and machine learning fundamentals to the ultimate test. I'm literally so excited for this because instead of just, talking at you for the next few minutes, we're actually going to work through all this material together. That's right, we're totally skipping the traditional syllabus today and jumping straight into a gamified knowledge check. We've got 5 rounds, 10 questions, covering everything from the project lifecycle to statistical analysis. I'm going to ask a question, give you a few seconds to lock in your answer, and then we'll break down the concepts together. So get those mental gears turning. Let's see if you can truly think like a data scientist. All right, let's just dive right in. Round 1. We're starting with the sheer scale of the industry. Here's your very first question. How much data is the entire world expected to generate by the year 2025? Think you know the scale of our global digital footprint? I'll give you a second. All right, you got a number in your head? Let's see if you're even close. The answer is a staggering 175 zettabytes. No way, right? To put that insane number into perspective, if you tried to download 175 zettabytes on a standard internet connection, it would literally take you millions of years. This absolute explosion of digital information is exactly why data science is such a critical, cutting-edge field right now. It's also why data scientists are in such crazy high demand, commanding an average U.S. salary of nearly $138,000. But all that data is completely useless unless someone can actually extract meaningful insights from it. Okay, moving on to our next question in round 1. What is the fundamental difference between data science and machine learning? These are pretty much the 2 biggest buzzwords in tech right now, and honestly, they're constantly used interchangeably by mistake. So how would you define the boundary between them? Give it some thought. All right, let's break down the actual difference. So the really crucial point here is that data science is the broader, interdisciplinary umbrella. It uses math, statistics, and programming to pull insights out of both structured and unstructured data. Machine learning, on the other hand, well, that's a very specific subset of artificial intelligence. It focuses entirely on algorithms that allow computers to learn from data and make decisions totally automatically, without human beings explicitly programming them to do so. Awesome. Let's move to round 2. Knowing there are literal zettabytes of data out there, what is the most time-consuming phase of a data science project lifecycle? Like, which step is going to eat up the absolute majority of your calendar? Have your guess ready? Let's check your intuition. If you said data processing, you hit the nail on the head. This is the grueling behind-the-scenes work of data science. You have to meticulously clean, map, normalize, and transform massive, super messy, real-world raw data into a high-quality format. You're constantly handling inconsistencies, removing duplicates. You simply cannot build a good predictive model on bad data. And that is exactly why this phase takes the absolute longest. Sticking with the life cycle for our next question, what are the 6 specific stages a data science project goes through from idea to finish? Can you map out the entire progression in order? Take a few seconds, try to list them mentally. Okay, let's see how many of the 6 you actually remembered.
Let's see how this builds from start to finish. Pretty much every successful project follows this exact flow. Number 1, business case and discovery. That's where you sit down with stakeholders to really define the problem. 2, data processing, which we just learned is the longest phase. 3, model planning, where you explore the data and pick your algorithms. 4, model building and selection. 5, presenting your results. And finally, number 6, deploying the model into the real world alongside the operations team. The whole shebang.
All right, welcome to round 3. We're focusing on analytics now. Here's your question. Which type of analytics answers the question, what will happen, and which type answers, how can we make it happen? You need 2 specific terms here. Got them? All right, let's look at the progression. This brilliantly illustrates the progression of difficulty in analytics. Predictive analytics uses statistical models and past data to basically forecast what will happen, giving us that crucial foresight. But the most difficult and honestly most valuable level is prescriptive analytics. That's where the data actually suggests actions, answering how can we make it happen, or even how do we prevent it. It's basically the difference between predicting a machine is going to break and the system automatically prescribing the exact maintenance schedule to stop it from breaking in the first place. You are doing great. Let's jump straight into round 4, data types. So if you survey customers and give them options ranging from very satisfied to very dissatisfied, are you collecting nominal or ordinal qualitative data? Pause for a second to really think about what those two words actually mean. Okay, here is how they differ. Survey ratings are ordinal qualitative data. Why? Well, because they have a clear logical ranking. Very satisfied is clearly higher or better than dissatisfied. Nominal data, on the other hand, just provides unique labels with no real hierarchy at all, things like hair color or gender. You can't mathematically rank blonde hair over brown hair, right? So that would just be nominal. Let's try one more on data types before we hit the final round. Is the number of students in a class considered discrete or continuous quantitative data? Think about how you actually physically count the people in a room. If you pictured whole numbers, you are definitely on the right track. The answer is discrete quantitative data. Discrete data represents countable items that simply cannot be subdivided. Put simply, you can't have half a student. Continuous data, however, can be infinitely subdivided into fractions and decimals. Think of things you measure rather than count, like temperature, time, or a person's exact height. All right, we've made it to the final round. Round 5, statistics. Here's your question. Which measure of central tendency is best for finding the most common category in qualitative data? Think of your basic statistical tools. Which one fits best here? Let's reveal the term. The answer is the mode. While the mean calculates the mathematical average and the median finds the exact middle number, the mode simply identifies the value that shows up the most frequently. If you want to know the most popular car color on a dealership lot, you don't calculate an average, right? You look for the mode. Okay, next question. What specific visual tool and what metric best captures the middle 50% of your data while ignoring wild, extreme outliers? Like, if you have messy data just completely skewing your averages, how do you visualize the true core of it? Let's look at the tool. Notice how effectively a box plot handles outliers here. The metric you're looking for is the interquartile range, or IQR. The box plot visualizes this perfectly by drawing a literal box between the 25th and 75th percentiles. This gives you the solid middle 50% of your data, totally cutting out the noise of extreme highs or lows that might otherwise distort your analysis. Here we are, the final test. In a perfectly normal distribution, what is true about the mean, median, and mode? Imagine a perfectly symmetrical bell curve on a graph. What happens to those three measures of central tendency? Take your final pause to think it over. Okay, let's see how you did. If you guessed that they are all perfectly equal, you absolutely nailed it. In a true normal distribution, the mean, median, and mode all sit perfectly stacked at the exact center peak of that symmetrical bell curve. Exactly half the data falls below that point and half rises above it. If you got that right, wow, you are truly thinking like a data scientist, for sure. We've covered the explosive volume of data, the messy but absolutely vital project life cycles, how to categorize information, and the statistical tools to just make sense of it all. So, now that you understand how to turn raw data into actionable foresight, the only real question left is, how are you going to use this knowledge to revolutionize your own work tomorrow? Thank you so much for playing along with this explainer, and I seriously can't wait to see what insights you uncover.